Okay, over here we have a graph of the function x cubed plus x in the numerator divided by this trinomial, x to the fourth plus 2x squared plus 1, the quantity to the fifth power. And if we're going to integrate that function from -1 to 1, you can see that it looks like this area right here is equal to this area right here. But the area down here is negative, and the area above the x-axis is positive. So we would expect an answer of 0, and indeed, that's what you get. A more interesting problem perhaps would be to find the integral, definite integral from 0 to 1 of this function. The question is, how do you arrive at this answer of 0 without a graph? Well, I did this in terms of x to start with so that I could use something called u substitution. And that's the first thing you should probably look at when you have a rational function like this. If you let u equal this denominator right here, this part of the denominator, when you take the derivative of that, does the numerator sort of in some way match? And you can see that it's very close. It's just got this factor of 4 that we need. And I like to just put it right here. If I put a 4 there, I have to put a 1/4 out front. And now the idea is that this whole expression right here, that's really du. So I'm ready to do u substitution. 1/4 of the definite integral. Well, that's the reason I put these labels here, x equals -1 to x equals 1, because when x is -1, what is u? Well, if you put -1 in for u, you get 1 plus 2 plus 1, or 4. If you put 1 in for u, guess what? You get the same thing. You're done, because we have a theorem that says if you have the definite integral of some function from a to a, that value is going to be 0. So we're done. We don't have to do anything else. Now, if I change this to a 0, then we got more work to do. Instead of u goes from 4 to 4, if I put 0 in here, I'm going from 1 to 4. U equals 1 to 4. This numerator and the dx becomes du, and I've got u to the 5th down here, which I can write as u to the -5 du. I'll go ahead and go that far. So 1/4 definite integral from 1 to 4 of u to the -5 du. So the antiderivative of u to the -5 is going to be raise the exponent by 1, multiplied by the reciprocal of the new exponent. And we're going to evaluate that from 1 to 4. And, well, let's see. I don't have a copy of that right here. Let me get a quick copy. And paste this in. And there's what you get, which matches what we had right here, using Desmos to actually calculate the definite integral from 0 to 1. If you do this, you get the same exact value, 0.0622, blah, blah. Okay, there you go. Hope that helped. If you have any questions, post a comment.